Oh, didn't see you there. Welcome to math. We're doing math. We're talking about pattern rules and growing patterns and patterning tables. Okay? So we're talking about patterns that grow, that follow a certain rule. Okay? And I think we learned before, this was an awesome example. So let's just find one that, whoops, wrong screen, is going to make sense. Okay? Okay. Here's an awesome example. Okay, they even have a patterning table here. So here's our first term in our pattern, okay? This isn't the kind of pattern that goes like A, B, or like circle, square, or repeats the same thing every time. That's a kind of pattern. This is a growing pattern. A pattern we can graph on a patterning table, okay? So my first term, all right? It has 1, 2, 3 straws in it, okay? Here's the patterning table. First term, 3 straws. Here's my second term. I have 1, 2, 3, 4, 5, 6. I have 6 straws, okay? Third term, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So my pattern is growing. What's it growing by? I can see it, and when I put it on a patterning table, I can see it really easily. What's it growing by? Nice and loud. KJ?
It is growing by 3s, and can I go to the bathroom?
Yes, and yes. Okay. He's going to the bathroom. Thanks, KJ. All right, it's growing by 3, so plus 3 each time. Okay? What am I going to look for? Like, what are the real values of that patterning table? What can I do with that makes it really useful? What can I look for on that patterning table that makes it really useful? Is it R word? And it ends in ships. What am I looking for? Aubrey?
Relationships.
Ooh, relationships. Because you're sitting right there, it can totally hear everything that you're saying back and forth, which is super embarrassing. It's on YouTube forever now. Relationships, okay? So I see one here. My number is growing by 3 each time. I'm also going to look across the table. So a relationship here. And these are going to be multiplicative relationships, okay? In this case, I already know one. I'm adding a group of 3 each time. 1 to 3, 2 to 6, 3 to 9, 4 to 12. What multiplication relationship exists there? Any ideas? What relationship exists there? Caleb?
Multiply the number by 3 each time.
Times 3 each time. So 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. So here's a patterning table where I can jump way ahead and use that pattern to my advantage, okay? The 10th term would just be 10 times 3, which is 30, okay? The 52nd term would just be 52 times 3, which is 165. Okay? Yeah, I did that math real fast, didn't I? He's impressed. Okay? So that's where the pattern table comes in really handy. Will that always work? No. There won't always be relationships across the table like that. But when there are, we can use them to our advantage to skip way ahead in our pattern. Okay, here's an awesome example. It's sideways. And I don't see their patterning table. They had one. I don't see it. We can make it as an awesome example. Okay, we'll make it right here. Okay, term 1. How many straws in term 1? David? 4. He's right. Once in a while that happens. All right, there's 4. There's 1, 2, 3, 4. That's good, eh? There's 4. But wait, I've added not 4 more. What did I add? This is a cool pattern. Quinn?
You got it 3.
I've added 3. So term 2 is 1, 2, 3, 4, 5, 6, 7. Okay. So term 3, I add 7 more. I'm at 10. Term 4, I've added 3 more. I'm at 13. Okay. So here's my patterning table. In this case, I have a relationship this way. It's plus 3 each time. Do I have a relationship across the table? Not really, because 2 times nothing is 7. There might be something in there. I'd have to look pretty close to find it. But it's possible that something is in there. David?
1 times 4 is 4.
1 times 4 is 4. That's true. 1 times 2 is not 7 though. 3 times 4 wouldn't be 10. I mean, there could be a pattern in there. Might require some careful looking. Okay? And sometimes it's a bit of a longer, like it requires some, like maybe it's times 2 minus 1 each time or something, right? And it might be in this case because we're putting on 3 each time. So I wonder if it's times 3. Oh. Ooh. Do you see anything, Mateo? What's 2 times 3? What's 2 times 3? A new hand? Curtis? 6. Okay. 2 times 3 is 6 plus 1? 7. 3 times 3? 9. Plus 1? 4 times 3?
12.
Plus 1?
13.
So there is a relationship there. It took a bit of digging, right? But it's like t for the term times 3 plus 1. Awesome.
No.
So I could plug in the 100th term times 3 plus 1. I would get 301. So the 100th term, it follows a pattern, is 301. Okay? So now, when I do a quiz on pattern rules and patterning tables, all y'all can just watch this right here to practice, okay? Term plus the value of that term, what's in that term, okay? And then look for some patterns to help you jump ahead, okay? Thanks for watching, Math.
Bye.